Now we have the idea of a sample space. A sample space is a complete set of equally likely outcomes. By a complete set, I mean a set of outcomes that cover every possible event. And there's more to it. Those equally likely outcomes can't overlap. So I could say equally likely, non-overlapping events or outcomes. Okay? So would this be a sample space? 2 heads, 2 tails, 1 of each. You should think about this for a minute if you haven't already seen this. And don't read ahead. But if you think about this, hopefully you realize that the 1 of each appears to not be equally likely with the other 2 events, the 2 heads or 2 tails. Now certainly these are non-overlapping events. You get 2 heads, 2 tails, 1 of each. None of these overlaps any of the others. If you get 2 tails, you don't get 2 heads, you don't get 1 of each. If you get 1 of each, you don't get 2 tails, you don't get 2 heads. If you get 2 heads, you don't get 2 tails, and you don't get 1 of each. And this spans all possible outcomes, but it's a complete set, but it's not equally likely, because 1 of each is more likely than 2 heads or 2 tails, presumably. Okay, well, we can see why that is, but this would be a sample space. The heads, heads, tails, tails, heads, tails, tails, heads. Looked like it's plausible that it's equally likely. We didn't prove it. We can flip as many coins as we want, and we'll never prove this. But this is the way we kind of expect it to work, and this is the way it pretty much worked out. Okay, these are all, say, 18, 17 and a half, plus or minus 3 and a half. Okay, sample space, heads, 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 tails, tails, heads, tails, tails. Again, if it's this, it isn't any of these. If it's this, it isn't any of the other 3, etc. And there's nothing else that can happen. It's got to be one of these 4. They're all equally likely. And it was observed. One student observed that, well, for example, to get heads, heads, you got a 50-50 chance of getting heads and a 50-50 chance of getting the next head. 50% of 50% is 25%, half of a half, and that comes out to a 25% probability. That's thinking ahead a little bit, and we'll look at that systematically. The point is that these 4 things are all that can happen. If you flip 2 coins, there's 100% probability that one of these things is going to happen. If they're all equally likely, then each one will be a 25% probability, or a probability of 1/4. Okay? Another way of saying it, we can draw a tree diagram. Okay? You flip the first coin, you're going to get heads or tails. Having flipped the first coin, if you got heads, then you're going to flip the second, you're going to get either heads or tails. If you got tails in the first, then you're going to flip the second, and you're going to get either heads or tails. So that you have the possible outcomes: heads, 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 tails, tails, heads, tails, tails. Same as what we've listed up here. We can also list the probabilities. 50% probability that we're going to get a head, 50% probability we're going to get a tail on the first flip. Now, having gotten, let's say, if we got a head on the first flip, then we'd have a 50% chance of getting a head, 50% chance of getting a tail on the second flip. Similarly, if you got a tail on the first flip, then you have a 50% chance of getting a head, or 50% chance of getting a tail on the second flip. Each of these possible events, each of these paths through the tree out to the outermost twig involves a 50% probability and then another 50% probability. And the way we read this is to get a head-head, you get a 50% probability of a head here, then only 50% probability of that to get a head-head. So the head-head comes with a 50% of a 50% probability, or 25% probability. Just noticed my collar was crooked. I've been walking around with that all day, and I'm mortified. Okay, so we have 25% probability of this, and similar analysis is going to give us 25% probability of each of the other possibilities.